Welcome back, Gangies. We're back once again. We had quite the interesting leak coding session yesterday, but desperate times call for desperate measures. So, uh, we had to get serious right meow yesterday. So, uh, we had to do the thing. So, I hopped on my phone. I was doing it on my phone. So, as we can tell, the last week it's been a slow descent into madness. We found the most ergonomic leak code position, which turned out to be in bed. And then we found the most ergonomic leak coding device, which happened to be the modern smartphone. So that's kind of flames. So that's kind of a rat. I'm not gonna lie. I only did it on my phone because I was strapped for time, and also I was my only option at the time. But now I'm thinking it might be the only way to do leak code. So we found the most ergonomic position, and what better place to use a phone than in bed? So that's where we're basically where we're at. So yeah, so that's where we're at, and it was actually kind of fun. So I expected it to be a much worse experience, although LC kind of did us dirty. It turns out you can't actually access the coding window on mobile phones, maybe because of the display resolution or something. But if you go on the Chrome browser and you request the desktop version of the website, you get access to it. But they still did us dirty in the end. So we'll be talking to the LeetCode developers about that very soon. It was unacceptable. But yeah, we're back once again. Things have been kind of crazy, so I think we should be good to do a regular 30-minute session today. That is not too bonkies, but we have a couple of comments that we have not been able to get to because of reasons we just mentioned, but that's kind of where we're at. Also, shout out to all the people in Discord. It's been pretty dope to see all the love and just all the people hanging out, doing things, working on problems. We're pretty much solving every modern problem for a man within the Discord. So if you're interested in that sort of thing and kind of just saving the world, you should definitely join the Discord. So that's kind of where we're at. And we do have some comments, so let's take a look from Josh Hightech. Pretty cool name, even cooler guy. Keeping the streak alive no matter what. Much respect. Oh wait, Mark, keyboard isn't working. Give me 1 second. Okay, what is going on? Every day there's a new trial. Something is challenging us. Okay, I think it's working. Yeah, so big shout out to Brody right here. I'm just trying to get like you, big Brody. Let's get to it. Feel strong, man. Keeping the streak alive. The leak code must be done. So a little way goes a long way. So hopefully we'll have something to show for this at the end of the year. But at this point, we're just doing easies. So, oh man, I wish we were doing mediums. I feel like a huge imposter since we're not really doing any mediums yet. But you know what? I'm gonna be the guinea pig or the test subject. I'm gonna do all the easies first, and then we'll see if we start cooking the mediums. And then we'll test the hypothesis that mediums are just made up of concepts from easies and so on. But we could just end up looking like a buffoon. In that case, I will take it because buffoonery is necessary. So I'm also sort of sick, you could probably tell. We have a legendary comment from Thomas Wong Coding, the God Prince, the King, the God King. You are unstoppable. We are unstoppable. I'm going to talk to the LC devs to up the difficulty because the Discord is growing at a rate of power that is simply too strong for the power for the questions given. Simple as that. Simple as that. The people in the Discord, their power levels are multiplying at a rate never before seen. So I was the first person in the Discord, but now I'm kind of bottom tier. They have people in the Discord who are cooking up storms. It's actually kind of crazy. Actually, let me check something real quick. So it is actually bonkies. The people in the Discord going conky dong, and there's not much else to say about that. Then I'm just trying to get like them. And then we have Martin. This man cannot be stopped. Feel strong, man. Yeah, I appreciate the support. It was a battle. It is definitely a battle. But hopefully we'll have something to show for this eventually. Because we are still super noobing. So we have Sali Akram Joy, which, you know, is a pretty cool name. I enjoy saying it for some reason. I think you should attend the LeetCode weekly challenge and make vids. By the way, which anime are you currently watching? I think we used to do the weekly challenge vids, but I kept forgetting. And that's a big issue with the system. I forget a lot. But we could start doing that again. And we'll spend one day a week doing, you know, trying to see how far we get in the competition. Because we need to get ranked. I don't know how many things does it take to get ranked. Because if we get ranked, that would be pretty cool. Or do you have to complete the contest? I think you have to do the contest live to get ranked, which is an issue because we'll never do it live, I think, which is unfortunate. But which anime are you currently watching? I'm currently watching Blue Lock. I was watching Chainsaw Man, but that is over. I was mostly watching Chainsaw Man is pretty cool. I read the manga a long time ago, and I was mostly watching it to see, just because it's been beautiful to watch. The directing has been impressive. Cinematography too, has just been crazy. Also the scenes and seeing how they finally were able to make a 3D pipeline work in animation is pretty incredible. What else are we watching? I think that's about it. I was also watching My Hero, which is, that show is going Bonky Kong as well. But I've also read the manga and I'm caught up. So I know everything that's going to happen, which is unfortunate. But I don't really have anything else to watch. That's kind of where we're at on that. Also, I'm not watching Hunter x Hunter right now, but that is just a goated show. But yeah, I could use some Rex though. How about you, brother? What is on your watch list currently? Then we have T Wong coming back in with some wise guidance, some sage-like guidance. Mediums can range a fair bit, so you could be stuck on those for a fair bit of time, maybe even years. I suspect I'm expecting an exponential increase in problem-solving speed. So we thought this would happen with the easies, and it has happened. So we first started doing the easies. We were doing like 1 or 2 easies a day. Then we started doing 3. This was in 1 hour. Now in 30 minutes, we can do like 2 or 3. If we were doing the original hour every day, we would be cooking at least 5 easies. And then we would be done all of the easies in 2 months. But we're trolling. So there's other things to do, which is unfortunate because I really want to make number go up so my brain can have some enjoyment. But I suspect an exponential increase in problem solving speed once we begin the mediums. Hopefully that's what will happen. But yeah, some of those are really difficult. Some easies, I think there were like 1 or 2, I don't remember how many. There are 1 or 2 easies that people said were supposed to be simple, and they're absolutely bonkies. It's at least medium style easies. But that is where we're at. And I think, yeah, I always appreciate the comments. We're able to stall before we have to begin our daily suffering. But yeah, so I think we're going to jump straight into the session. Oh yeah, I forgot we did it on phone yesterday and we never finished this problem here. So we're working on binary prefix divisible by 5. So we pretty much have a problem. We're given a binary array nums, 0 index. We define x sub I as the number whose binary representation is the subarray from nums to 0 ... I. From most significant bit to least significant bit. For example, if nums is 101, then the number, right, that exists at x sub 0 would be 1, right? Because there's only 1. If we go to x or index equal 1, we have 1, 0. In binary, this 1, 0 would represent 2. And then when we go to the third index, which is really index 2, we'll have 3 numbers, which this really represents the number 5, right? Because 1, 2, 4, 4 is set to 1, and 1 is set to 1, so we have a total of 5. We need to return an array of booleans answer where answer sub I is true if x sub I is divisible by 5. We made a version of this but it runs in n squared time, and we run out of time limit exceeded. It doesn't seem possible to do this in linear time. This is because we're at 101, right? It's represented from most significant bit to least significant bit. We can't use any. Oh, we guess we can. I don't think you can shift. Maybe you can shift big ends. Well, let's test, right? We're gonna say num is equal to big int shifted 1. If we click run, it shouldn't change the answer, but I don't think you can. You can bit shift. Okay, well if you can bit shift, then we can actually just, okay, we can do this in linear time then. Interesting. So that's actually an interesting idea. So if we can bit shift, then we can just create the number going from backwards to frontwards. What I mean by that is we'll start with 0 or add 1, right? Which I guess is divisible by 5. We know it's not. So we can just add the number to the binary, right? And then we can shift it. Oh. Yeah, and we'll shift it left. Yeah, I got confused. We have to go from the front though. So I think we'll comment all this stuff out. And then we'll actually have one number, right, which starts at big int, which starts at 0. Right, and then from here we just have to say, since we're going forward, we'll just say num is equal to num and num or nums sub I. But the first, oh wait, we already have, you're right. Right, and then we'll bit shift it left once first. We have to put an N here. Nice. So that's actually pretty cool. I didn't know you could actually do the same operations on Big Ant. So shout out to those people who worked on this, because that's pretty crazy. So now we have, you are given an integer array digits where each element is a digit. The array must, you're given an integer array digits where each element is a digit. Integer array digits where each element is a digit. The array may contain duplicates. You are given an integer array digits where each element is a digit. The array where each element is a digit. Given an integer array digits where each element is a digit, the array may contain duplicates. You need to find all the unique integers that follow the given requirements. The integer consists of the concatenation of 3 elements from digits in any arbitrary order. Does not have leading zeros. See how many numbers they give it to us. Can have up to 100 digits. So we could do this with an answer array. then I guess you could sort them in ascending order and then return answer. The way I think we could do this is just in n cubed time. We could just try all the combinations. And we can filter out no leading zeros by having the first one skip zeros. Integers even. So yeah, I think we can do that. The first thing we'll make sure, right? We want to filter out leading zeros. So if digits of I equals 0, we'll do continue. And then secondarily, we probably have to make sure that they're separate digits, right? So we'll say I does not equal J, and J does not equal K. We'll say the number is going to be equal to parse int of digits of I, digits of J, and digits of K. And we'll say if num mod 2 equals 0, then answer dot push num. And I think we need one more. And K does not equal I. We also probably want to stave off against duplicates. We can just do set.add none. Answer will just be equal to the values in the set spread into an array. This one is very slow, but it is what it is. I wonder what the time complexity of this is. I think you have this at least n cubed. and we're sorting, and I'm pretty sure n cubed dominates the sort. So I'd say n cubed plus n log n. There's a linear time solution. Here we have given two binary trees, original and cloned. Well, the problem is called find a corresponding node. Find a corresponding node of a binary tree. Find a corresponding node of a binary tree in a clone of that tree. Given two binary trees, original and cloned, given a reference to a node. Given two binary trees, original and cloned, and given a reference to a node. Given two binary trees, original and cloned, and we're given a reference to a node target in the original tree. The clone tree is a copy of the original tree. Return a reference to the same node in the clone tree. Note that you're not allowed to change any of the two trees of the target node, and the answer must be a reference to a node in the clone tree. I hope all the nodes are unique then. So this is the original, the target is 3, and we have to find okay, if the values in the node are unique, then we can do this because we can just check the value. For the follow-up, could we solve the problem if repeated values in the tree are allowed? We definitely could not, at least not in JavaScript, since we don't have access to the memory. We don't have access to the memory address of the target. At least I think. This problem is confusing. Why would they give us access to original? Couldn't they just give us access to target? Actually, now I'm realizing in the follow-up, you could do it if the values are repeated, because you could encode the position of the node as a sort of XY coordinate that you could find in the next tree. I'm thinking we could just make a recursive function find, and we'll use an object so we can use pass by reference, and then in this function we're basically just going to try and find the value. So we're in the clone tree. We know that this is going to be a tree node or null. And it might just be better to say node. The target is also a tree node. And it won't be null. And this is just an object that has one property called found, which isn't any. Let's say if node, right? Then we'll check again. We'll say if node dot val equals target dot val, then we'll set object dot found equal node. At the end here we can return object dot found, and then if we don't find it, I mean if the node's value doesn't equal target dot val, then we have to keep searching. So we'll just do find node dot left with target and object. We can copy it. So we're at 33 minutes. I think we're going to stop there for today.